July 2025. Mark your calendars if they still work. Your morning routine evaporates. Coffee makers silent. Phones a paperweight. You twist the car key and get nothing. Just dead air. Right now, we're living through solar cycle 25, and it's already smashing every scientific prediction. NASA expected a quiet peak in 2025 with around 115 sunspots. But by mid-2024, that number had already exploded past 150. Solar flares are striking Earth harder and more often.
The fact that it is big has the potential to launch a lot of stuff towards us. Whether it will or not, and will it be aimed towards the Earth, we just don't know.
In May alone, X-class flares knocked out radio systems worldwide. And the worst part is that we have already entered solar maximum. The countdown's begun. So what happens when the next monster flare hits? One powerful enough to knock modern civilization offline for weeks, even months. Let's find out if we're ready or completely exposed. What we're witnessing right now isn't just another solar cycle. It's a cosmic awakening that has space weather experts genuinely concerned. According to recent reports, the Sun has been releasing explosive solar flares from highly active regions, with some of the strongest flares of 2025 already recorded. Solar flares are essentially cosmic lightning bolts, intense bursts of electromagnetic radiation that travel at the speed of light. They're classified on a scale from A, B, C, M to X, with X-class flares being the monsters that can wreak havoc on our technology. But it's the coronal mass ejections, or CMEs, that keep scientists awake at night. These are massive clouds of charged particles hurled into space at incredible speeds. And when they hit Earth, they don't just create pretty auroras. The difference between what we're seeing now and previous solar cycles is striking. Space Weather Live and other monitoring organizations have documented unprecedented activity levels, with the Sun consistently exceeding predictions month after month. This isn't just a statistical anomaly, it's a fundamental shift in how solar cycle 25 is behaving, and it's leading us toward a potential confrontation between our technology-dependent civilization and the raw power of our nearest star.
We right now are in a solar maximum. That's why we're getting such great northern lights over the last few months, few years, and that will start to wane, and then we'll have to wait 11 years for it to happen again.
Now, here's where the timeline becomes crucial, and why July 2025 has captured so much attention. As per original NASA predictions placed solar maximum right around July 2025, and so we're already deep in the solar maximum period. This means, rather than building toward a climax in July 2025, we're potentially looking at sustained high activity that could continue well into 2025 and beyond. Recent data shows that we've already experienced M8.1 solar flares and significant CMO impacts. These events have caused measurable disruptions to radio communications and satellite operations, serving as a preview of what sustained solar maximum conditions might bring. What makes this particularly concerning is that high sunspot numbers are anticipated throughout 2025, dramatically increasing the likelihood of large solar flares and Earth-directed coronal mass ejections. The transition from theoretical threat to practical concern becomes evident when we examine the recent severe geomagnetic storm alerts. NOAA has issued multiple G4-level severe solar storm alerts, with some events featuring CMEs traveling at extraordinary speeds. These aren't isolated incidents. They're part of a pattern that suggests the Sun's activity will remain elevated throughout the period that was originally predicted to be the peak of solar cycle 25. In order to understand what we might face, we need to examine what's already happened. The year 2024 provided us with a sobering preview, when an extreme G5 geomagnetic storm struck in May, followed by a strong G4 storm in October. These events, documented by multiple space weather monitoring organizations, caused technological disruptions across the globe and demonstrated just how vulnerable our modern infrastructure has become. The May 2024 G5 storm was particularly revealing. It knocked out GPS systems, disrupted radio communications, and caused power grid fluctuations across multiple continents.
The sun expels billions of tons of charged particles that travel through space, and once they reach Earth, they interact with Earth's magnetic field, compressing Earth's magnetic field.
What made this event especially concerning wasn't just its intensity, but how quickly it overwhelmed our technological defenses. Satellites were forced into safe mode, airlines had to reroute flights to avoid polar regions, and some power companies had to implement controlled blackouts to prevent more serious damage. Building on these recent experiences, the storms we've witnessed in 2025 have shown an escalating pattern. The solar flares are seen as one of the strongest of the year and have consistently caused radio blackouts worldwide.
Our sun has sent out the strongest solar flare of 2025, and it sparked radio blackouts.
Each event serves as both a warning and a stress test for our increasingly interconnected technological infrastructure, revealing vulnerabilities that could be catastrophically exploited by an even more powerful solar event. But what transforms these cosmic events from fascinating astronomical phenomena into potential civilization-threatening disasters is our complete dependence on vulnerable technology. When we examine the potential cascade of failures that could result from a major solar storm, the picture becomes genuinely alarming. Consider the GPS constellation that quietly underpins so much of modern life. According to space weather researchers, solar storms can disrupt satellite operations and navigation signals, affecting everything from smartphone maps to precision farming equipment. But the real concern goes deeper. GPS provides timing signals that synchronize power grids, financial networks, and telecommunications systems. When GPS fails, it's not just navigation that's affected. It's the invisible timing backbone of modern civilization. Power grids represent another critical vulnerability. High-voltage transformers, the massive custom-built components that form the backbone of electrical distribution, are particularly susceptible to geomagnetic-induced currents. These aren't components you can pick up at a hardware store. They cost millions of dollars each and can take months or years to manufacture and install. A widespread transformer failure could leave entire regions without power for extended periods, creating a cascade of secondary failures across every sector of society. The internet infrastructure, which we've come to view as nearly indestructible, reveals its own vulnerabilities during major geomagnetic events. Undersea cables carrying international internet traffic, data centers requiring consistent power, and the vast network of ground-based infrastructure all become potential failure points when confronted with the electromagnetic chaos of a major solar storm. While the technical failures capture headlines, the human cost of a major solar storm extends far beyond darkened screens and dead satellites. Modern hospitals operate with the assumption that electronic systems will function reliably. Life support machines, computerized drug dispensing systems, electronic patient monitors, and the digital networks that coordinate emergency medical services all depend on the same vulnerable infrastructure. Water treatment and distribution systems present another critical concern. These facilities require electricity not just for pumping, but for the computerized systems that monitor water quality and chemical treatment. Without power, cities begin running out of clean water within days, creating public health emergencies that compound the technological crisis. The financial system, which exists primarily as digital data flowing through electronic networks, becomes another casualty. When credit card systems fail and ATMs stop working in a society where most people rarely carry significant cash, commerce grinds to a halt. Supply chains that depend on just-in-time delivery and computerized logistics can't adapt quickly enough to function in a low-tech environment. These interconnected vulnerabilities create what disaster researchers call a cascade failure, where the breakdown of one system triggers failures in others, eventually overwhelming society's ability to maintain basic services and public order. Despite these sobering realities, it's important to understand that Earth itself is remarkably well protected against solar violence. Our planet's magnetic field, generated by the molten iron core spinning deep beneath our feet, creates an invisible shield that deflects most solar particles harmlessly into space. This magnetosphere, combined with our atmosphere, has protected life on Earth for billions of years, including through solar events far more powerful than anything we're likely to encounter. Even during the most severe geomagnetic storms, the actual radiation reaching Earth's surface remains well within tolerable limits for biological life. The aurora displays that accompany major solar storms are actually visual evidence of our planet's protective systems working. They show solar particles being safely channeled away from populated areas toward the polar regions. This natural protection explains why solar storms pose primarily a technological threat rather than a biological one. The same electromagnetic effects that can fry sensitive electronics barely register on the robust biological systems that evolved over millions of years of solar variability. From a planetary perspective, solar storms are routine space weather, not existential threats. However, this natural resilience doesn't extend to the artificial systems we've built. Our technology, designed for the relatively stable electromagnetic environment we normally experience, becomes vulnerable precisely because it's so much more sensitive than biological systems to electromagnetic interference. Understanding these realities has led to significant efforts to harden critical infrastructure against space weather events. Power grid operators in many regions have installed monitoring equipment and developed protocols for protecting transformers during major geomagnetic storms. Some utilities can now shut down vulnerable equipment before a storm hits, preventing permanent damage while accepting temporary outages. Satellite operators have become increasingly sophisticated in their approach to space weather. Modern satellites are designed with radiation-hardened components and can be placed in protective modes during major solar events. Ground control teams monitor space weather forecasts continuously and can take preventive action when dangerous conditions are predicted. The aviation industry has developed comprehensive space weather protocols, routinely rerouting flights away from polar regions during solar storms and maintaining constant communication with space weather monitoring centers. These measures have proven effective in preventing the communication and navigation problems that could otherwise create serious safety issues for aircraft. Yet despite these improvements, the protection remains incomplete and inconsistent. While some critical systems have been hardened, many others remain vulnerable. The challenge is that comprehensive protection requires coordinated action across multiple industries and international boundaries, a level of cooperation that has proven difficult to achieve. As we move through 2025, space weather monitoring organizations continue to track elevated solar activity levels. The combination of already high sunspot numbers and predictions for continued elevated activity throughout the year creates a sustained period of increased risk rather than a single moment of peak danger. Recent severe geomagnetic storms have provided valuable real-world tests of our preparations. Each event reveals both improvements in our defensive capabilities and remaining vulnerabilities in our systems. The pattern emerging from these incidents suggests that, while we're better prepared than we were a decade ago, we're still not fully ready for a Carrington-level event. The scientific consensus points toward continued vigilance rather than panic. Solar maximum periods typically last for several years, meaning that the elevated risk we're experiencing now will likely continue well beyond July 2025. This extended timeline actually works in our favor, providing more opportunities to identify and address vulnerabilities before they can be exploited by an even more powerful solar event. What's particularly encouraging is the continuous improvement in space weather forecasting. Modern satellite monitoring provides us with early warning systems that give us anywhere from minutes to days to prepare for incoming solar storms, depending on the specific type of event. This advanced warning capability, which didn't exist during previous solar maximum periods, represents our best defense against being caught unprepared. So, will solar flares destroy Earth in July 2025? The planet itself will survive just fine. It's weathered far worse over billions of years. But our modern civilization faces a genuine test of resilience as solar cycle 25 continues exceeding all predictions. The evidence from recent severe geomagnetic storms, the unprecedented solar activity we're already witnessing, and the sustained high activity predicted throughout 2025 all point to a period of elevated risk rather than a single catastrophic moment. We're more prepared than ever before, but we're also more vulnerable than any civilization in human history. The real question isn't whether solar storms will impact us. They already are. The question is whether we'll use this knowledge to build a more resilient technological civilization or continue living on borrowed time. What do you think? Are we ready for what the sun has planned? Share your thoughts below and subscribe for more deep dives into the science shaping our future.